Today we're going to cover the second half of 11.6, or maybe not necessarily the second half, but the second part. We're going to work on everything we did with our numbers, but this time with variables. Alright, so we're going to reduce radicals, just like we did with our numbers, only this time we have variables. So we're going to rely on the fact, I'm going to tell you the first one, the square root of x squared is equal to x. So anytime you have the square root of x squared, just know that it equals x. Alright, so we're going to rely on that fact to do the rest of the problems. The next example, we have the square root of x squared y squared. So if you have two things that you're multiplying, or more than two, you can break that up and say it's the square root of x squared times the square root of y squared. Well, the square root of x squared is just an x, and the square root of y squared is equal to y. And our final answer is x times y. Alright, so now how do you square root something that's raised to the third power? We know that the square root of x is equal to x from above, but what's the square root of x cubed? So the way that we approach this is, I'm going to kind of show more than what we might need to, just as I explain it. We're going to take this x cubed and break it down. I want to know how many x squareds fit in that. So there's an x squared, that's two of our x's, and then we still have an x left over. So if I break it down even further, I can say square root of x squared, square root of x, and then the square root of x squared is an x, so that just became an x. And then the square root of x, in order for us to square root a variable, you have to have at least two of them in there. Because that's x to the first power, it's just going to stay as the square root of x. Alright. Now, square root of x to the fifth power. Now, we do want to kind of follow the same idea as the last one and figure out how many x squareds fit in. So, again, I'm writing down all the steps just in the explanation here. We have x squared, that's two of them. Well, here's another one that gets us up to 4, but we have 5 because it's x to the fifth. So there's our fifth. So if you notice, we still have, this is still x to the fifth, it's just broken down. Now, the square root, now you can break it down even further, square root of x squared, there's the first one. Here's the second one, and then there's the x. The square root of x squared is x, square root of x squared is x, and the square root of just the x stays. It's kind of confusing if you just listen to it, huh? And then our final answer, since these x's are both out in front of the square root, you can go ahead and multiply those together and say x squared square roots of x. Alright, so how can we do this problem without having to do all of this work right here? So here's kind of the shortcut way to do it, and just fall back on this if the shortcut seems kind of confusing, but the shortcut will save you some time. So the way that the shortcut works is if you have the square root of x to the fifth, you want to look at that 5 and say how many x squareds fit in there. And we wrote it out, we could see that there were 2 of them, and in your head if you can come up with 2 of them, so how many x squareds or how many groups of 2 fit in? Because we got 2, that means that out front you're going to have an x squared. That's what tells us what our exponent is how many groups of 2 fit into that 5. So that gets us up to 4, because you had 2 groups of 2, and then you're left over with just 1 x. And there's our final answer, kind of working through the shortcut. We'll work on that some more. Alright, so reduce each radical. First one, if we break this down, you have the square root of 4 and the square root of x to the fourth. Well, the square root of 4 we know is 2. And now we can do that shortcut, the square root of x to the fourth. So look at the 4. How many groups of 2 can you fit in? Well, you can have an x squared and an x squared. That's 2 groups. So x squared. Do you have any x's left over that stay inside the radical? No, you do not. So just 2x squared. Alright, next one. You have square root of 25, square root of x to the 7th, and square root of y to the 6th. So I'm just going to talk through this one. The square root of 25 is 5. Now the square root of x to the 7th, how many groups of 2 can you fit into 7? So 2, 4, 6, we can fit 3 of them. So that gives us an x cubed out front. But that only gets us up to 6. So do we have any leftovers? And yes, we have an x left over. So I'm going to leave a space for the y, and I'm going to put that x underneath. And now the square root of y to the 6, how many groups of 2 fit into 6? Well, there's 3 of them that fit in there, so we're going to have y to the 3rd power, because you could fit in 3 groups of 2. Do you have any leftovers? No, you do not, so you don't have anything left over in there. So there's your final answer. All right, square root of 18x to the 5th. Well, can we take the square root of just an 18? No, we can't, so we're going to work on reducing that like we reduced in the last lesson. 18 can be broken down into 9 times 2, and the square root of 9 is 3. I'm going to leave a space for any x's, and that 2 stays underneath the square root. Now we're going to look at our x's. We have x to the 5th power. So how many groups of 2 can you get out of 5? You can get 2 of them, so x squared goes out front. And how many x's do you have left over? Just an x. So remember, this variable out here tells you how many groups of 2 you took out from the radical. So really, there's 2 groups of 2, meaning this accounts for 4 of them, which is why there's only 1 left over in there. All right, next one, square root of 20. Let's break it down. We can break it down into a 4 and a 5. So the square root of 4 is 2. I'm going to leave some space, square root of 5. Now, the square root of x, like I said before, you have to have at least 2 of them to take the square root. So that x, you can't square root it, so that stays. And then y to the 10th, how many groups of 2 can you fit into 10? 5 of them. So y to the 5th, and did you have any leftover y's? No, you did not, so that's our final answer. All right, here's our last slide. Kind of like we did the fractions last time, if you can reduce in here first, do that, and then square root. This first example, it's an x and a y. You can't reduce those together, so just square root each one. Square root of x just stays as a square root of x. We don't have enough x's to square root it. And then the square root of y squared is y. So that one is complete. Next one, let's go ahead and simplify that. That's going to give us the square root of, if you have x to the 5th over x cubed, that becomes x squared. And then what's the square root of x squared? Just an x. All right. So this next one, let's do some reducing. First we have the 4 over the 36. That reduces to 1 over 9. And then x squared over x leaves you with an x on the top, and it is the square root of that whole thing. Alright, so let's square root these separately. You have the square root of 1x is just the same thing as x over the square root of 9. Square root of x stays because we don't have enough to square root it, but the square root of 9 becomes a 3. Alright, next one we have this 7 over 9, which doesn't reduce, so we're going to leave the 7 over 9. But we can do something with those x's. X to the 5th over x cubed becomes x squared on top, and then we're square rooting that. So now we have a few things. You want to square root the 7, square root the x squared, and square root the 9. Well, square rooting the 9, that's the easy one. That's the 3. Square root of 7, you can't square root and you can't reduce it. And then the square root of x squared, because it's squared, there's 1 group of 2 you can fit out of that, so x to the 1st power goes out front. And that is that reduced answer. So these do get easier the more that we do, it just takes practice.